Hello everyone, today we are going to be doing some Blind 75 C++ Leetcode, and today we are working on longest palindromic substring. So, before we get started, make sure we run out all the questions we need to answer. We need to ask ourselves what the input's going to be, what data structure / algorithm / technique we need to use, what to do with the data, and what our output's going to be, just to give a whole walk down and breakthrough of the problem. Okay, so, given a string S, return the longest palindromic substring in S. So, overall, we already know what our input is. Our input's going to be a string of S. You can look at the parameters at the top. It's already highlighted up here. And then we need to return the longest palindromic substring in S. And to give a whole breakdown on everything, what is a palindrome? Well, a palindrome in particular is a word that can also, whenever you flip it, it would also be the same word at the same time, such as BAB would also be BAB, and then ABA would also be ABA. Now, what we need to do is that we need to find a way where we can keep track and count the number of times a character appears within our given string and keep track of every other one that has already been visited. But how are we going to do that? Well, today I'm going to introduce you folks to a concept called dynamic programming. For this problem, where dynamic programming is a method for solving complex problems by breaking them down into simpler overlapping subproblems, which are just breaking down. So imagine in yourself, instead of eating the whole elephant, you're taking bits and pieces of the elephant all together, so that way you can be able to structure out your problem. So it's taking the elephant bit by bit, and then you just expand upon the relationships over variables that you have already been given to start with, and what variables you can also keep track of. So what we are going to create, what we are going to do is that we will need to think of the string, and we would need to keep track of what we have already considered as well. So the first thing that's already going to be kept in mind is that we will create a vector where it will be a matrix to keep track of all the characters visited and if they are matching or not. The matrix will be called dp with n times n, and then what we are going to be doing is that for what we have already initialized when expanding upon the relationship, we're also going to have start and max length of our string, and then what we are doing with the following data, just expanding upon it, is that we will first loop through the string S from the end to start, because we're going to break up the string into two parts, and then in the next part we will from end to start, and in the same operation we will loop through the string S from the beginning to the end, and then we're going to check for every single character which has been visited and then and we're not necessarily storing, since we are not using a data structure. Well, we are using a data structure, a matrix really, in this case, but what we are doing is that we're setting the conditions of the matrix to meet certain Boolean conditions where we will be interacting with every single other character when breaking up the string from beginning to end to ultimately check that it is a palindrome. So I'll expand that even further as well, and then in the final part we will check to see if our matrix is true and the length of the current substring is greater than our max length. For if our max length is less than the current substring, we will update the max length, and because ultimately we want to return the longest palindromic substring that we have already found throughout the rest. Alright, so and finally what we will need to do is then return the longest substring. String. Alright. So we got 4 different steps that we need to break down. Let's get to it. Alright, so first things first, this is what we're going to do. We will first initialize our matrix, where it's going to be a vector, or hang on, prior to okay. I will actually, for sake of clarity, as stated again, we will initialize our string length, then we will, okay, there we go, that's a little better. Okay, so the first step is going to be s.length right over here. Then we're going to create our matrix, which is going to be a vector. dp with n, and our vector, that will be a boolean, and false. Then we're going to initialize our start, which will be 0, which is the beginning, and then our max length, which will set a default to 1, because every single string, every single palindrome needs at least another character inside. Then we're going to be looping through our string. So this is what we will be doing right here for int I is n minus 1, which is the string length minus 1. Since we're starting directly from the end, I is going to be greater than 0, I minus minus, since it's decrementing from the left side. And then we're going to set our matrix to true, given the fact that I and I would be a palindrome to start with, if both of them are the same. We will be iterating through our next step, which will be coming from the front. Int of j is going to be equal to I plus 1, since we are starting directly from the left-hand side, and then we have j is going to be less than the length of our string that we have, so it will be s.length, and then we will be incrementing j as well. Then what we will be doing, checking conditions for true for every character visited. These are the conditions we want. So if s of I is going to be equal to s of j, as a palindrome was already stated, and j minus I, given the, this is just where the value of our given character is, and if it's equal to the max length, which would technically be 1, or the matrix that we have, I plus 1, relative to j minus 1, since that would be technically the, when both of the strings have already met up to each other, since they're starting directly from the left and directly from the right as well. We would have dp of I and j be true. And we update our matrix as such. And then we will update our max length, where if j minus I plus 1 is greater than the max length, hence the characters that we've already done, we're going to update our max length accordingly, where it's going to be j minus I, given its position plus 1, since max length was initially 1, and then the start is going to be equal to where I is located, because we can even have I, A, B, A already located at one point to another. And finally, what we will be doing, since we have that, we're going to be returning our substring, where this is going to be called from the STL library at return.substring, the start and max length. I'm sure we got this right. Where n is the length right over here relative to our matrix that we have. For the sake of it, right. You can even do this for clarity at the same time. That's length. Oh, sorry about that. Right here, it would still be the same. Looks like it should be correct. Let's just make sure it's all good. Oh, hold on. So I'm gonna be sure I clean up it all. There we go. I had a feeling there was something like that. Alright, it passes all the test cases. Uh-oh, wrong answer. Okay, I put a minus up here. It should be equal, which explains why. There we go. It passes all the test cases. All right, and here we are. So let me just clean this up for you folks so that way you folks can understand where we are coming from. All right, right over here. And so just give a rundown on the space and time complexity of our following. Now, given the fact that we have nested for loops for the most part, our space complexity is going to be O. Well, first off, our time complexity is going to be O of n squared, given the fact that, one, we already have nested for loops where n is representing the length of the string, and since we're looping it twice, technically, initially, if we weren't looping it twice, we would need to have it be in constant space, constant time. And then with our space complexity, it's going to be O n squared, since we're using a Boolean matrix in order to keep the size of our following array. And since we are, one, scanning for the entire array, and then two, creating a substring as a result from it, our space and time complexity will be O of n squared. So yeah, this was the longest palindromic substring. If you have any questions in particular, feel free to put them in the comment section. Or if you liked and enjoyed this video, feel free to like and subscribe. And have any more requests or questions, feel free to put them in the comment section. Thanks again. Cheers. Bye-bye.